Hello, everyone, and welcome to our first LinkedIn Live on our Thursday Room Manufacturing Futures and on Industry 4.0 Club. We are here today joined with my co-host Ira Sharp, as well as joined with our guest Ralph Rio from ARC Advisory Group. And we want to definitely start here with welcoming everyone and thank you for joining us today. We are trying something new and really looking forward to this discussion on LinkedIn Live. And we definitely wanted to make sure that we are getting a good and interesting topic now on our first LinkedIn Live event here today. So our topic today is equipment as a service, and that is something where within the equipment manufacturing industry, there's an idea around selling your equipment in different ways, and one of them is as a full service opportunity. But there's definitely some hurdles that are a little bit bigger for equipment vendors as opposed to like software vendors that has been doing software as a service, platform as a service for quite a while. And so Ralph has been looking into this area and has identified, what is some of the business models around this, and what are some of the opportunities, and what are some of the areas that you can develop these type of solutions by. Ralph Rio has a deep experience with industrial applications. His career spans market research and consulting with ARC Advisory Group, marketing and product management with software suppliers, and engineering and manufacturing functions at end users. At ARC, Ralph's domain area includes blockchain, asset management, field service management, mobility, and industrial Internet of Things. And so lately here, as you can get from this, that Ralph has looked into this particular space of equipment as a service. Just want to quickly introduce myself before we go to other introductions here. My name is Jan Pingel. I am a co-founder of Industry 4.0 Club. When I'm not here co-hosting with Ira, I am a product leader from Ingersoll Rand, working in the digital solution space, IoT, where we're making our equipment smart and connected. And that's my quick story. Ira, on to you, and then we'll have Ralph introduce himself and start his presentation.
Thanks, Jan. So Ira Sharp here, and my day job is I'm the director of marketing at Phoenix Contact for all the automation equipment in the U.S. market. And when I'm not doing that, I get to spend a lot of time with Jan here on typically a Tuesday room on Clubhouse. But of course, we're making our first foray here on the LinkedIn Live. We're really excited about it. I really like to talk about Industry 4.0, open automation, different things like AI, ML, whatever it may be. If it's forward-looking in the area of manufacturing, I love to talk about it. So I'm super excited to have Ralph here today from ARC, because I know this is going to be a fantastic conversation. Jan?
Thanks. Yeah, so Ralph, please feel free to unmute and present yourself, or introduce yourself and introduce the topic, and then we are ready to go. Thank you.
Excellent. Thank you for that nice introduction and start of this this webcast. Just a little bit about ARC to kind of help you understand why you should listen to us. ARC essentially monitors new technologies and assesses or evaluates appropriate applications with them within manufacturing. And many of us have operating experience. For example, I ran a maintenance department at one time, and I've also been involved in the implementation of all kinds of automation and systems, all the way from robots on the plant floor up to ERP systems. So, and since then, after that, I've worked with suppliers, marketing, technology, and into the industrial segments, and the past 20 years with ARC, where I've written a lot of reports and advised a lot of people about technology adoption. So if any of you out there get interested in this and want to take it to the next level, contact me via LinkedIn. You see the contact on the bottom there, and we'll probably engage with you and see if we can help you out. So in terms of what I'll be talking about, really digital twin enables other kinds of things to happen, one of which is equipment as a service. So I'm going to be talking about it mainly from the business drivers. Why does it make sense for an OEM to adopt equipment as a service? And this is kind of a C-suite perspective. Then I'll talk about digital twin and 5G just a wee bit, and then go into some conclusions. After that, we'll have plenty of time for a Q&A. So, the C-suite, their metrics are very obvious. They're in the P&L statement and the balance sheet, and that usually winds up in shareholder value. What's the price of the stock? So anything that affects stock price will get C-suite attention. And in this case, let me just talk about price to earnings ratio. So a company has earnings, its stock has value on the stock market. So price to earnings is just the stock price divided by earnings. So in the case of software as a service, and my approach to this is I just went down the Fortune 500, picked out the first 3 software as a service companies who are pure software as a service. So that was Salesforce, Netflix, and Adobe. In fact, Adobe used to be on-site perpetual licenses, 100% of their business. And they've actually gotten to the point where they force their customers to go to software as a service. You cannot buy a on-site license from them anymore. And of course, people like Salesforce have always been software as a service. Well, you take an average of their P&E ratio, it's pretty high, it's 77. If you look at equipment manufacturers, and again, I just went down the list from a Fortune 5. No, it was the Fortune 500. From the top, first 3 pure OEM business model companies. That gave me Dell, GM, and Lockheed Martin. And you can see their average is a heck of a lot lower, 9.6. And then just the general average S&P 500, this is in January, was 26. So you see a huge difference between equipment manufacturers and software as a service. Well over 10-to-1 difference in their P&E ratios. So one can imagine anybody in the C-suite who works for an equipment manufacturer, if they could see a path to getting to the price to earnings ratios anywhere near close to SaaS companies, that would definitely get their interest. So let me just talk about that for a little bit. So what does software as a service, or in this case, equipment as a service, mean? Right now, the business model for OEMs is a lot of revenue on the initial sale, and then over time, there is some small revenue. Usually, it's parts, maybe some service, but the predominantly the OEM's revenue is based on the initial sale. And due to the changes in economy, this fluctuates a lot. So it is not, from a risk management viewpoint, this is not stable. Some industries more than other, but we see a lot of fluctuation based on economic trends. So that when there's a recession, the OEMs get slammed hard typically. And when business is booming, the OEMs sometimes have a capacity problem. So in addition to this large upfront recognition of revenue, we have a lot of risk around fluctuation of the revenues based on economic conditions. Now, with equipment as a service, now here I'm focusing in on the sale of a particular piece of equipment. With equipment as a service, you would have revenue on a interim basis, on a periodic basis, and I'm taking here annually. And typically the EAS revenue would be around 30% of the value of the equipment. So you take that over 10 years, and 10 times 30% is 300%. So over the 10-year period, you're much better off. But initially, the first 3 years, not so much. But let me take this on a broader viewpoint in the next few slides. So here, looking at the total revenue of the OEM, not just for one piece of equipment, and I'm assuming just for the moment here to make the analysis simple, that the OEM's revenue is flat. So we're showing the same revenue in blue here over 6 years in this particular case. So if somehow miraculously all of the revenue is converted to EAS, year one for that year one's equipment sales is the green. Now, if we go to the next year, year one continues and year two builds on top of that. Then you go the next years and you can see where incrementally, eventually the revenue is much higher than the pure equipment sales. And certainly when you start getting to year four, that's very bullish for the stock value. There is what I'd call this knothole of the first 3 years where revenues will be lower. And then there's a huge kick benefit in the years afterwards. I will comment that in the case of the software as a service companies, to get through this first 3 year knothole, some of them basically took longer than 3 years to implement this, so that the decline was not obvious to stockholders in the stock market. Other companies who went through this more quickly, Infor is an example, they went private for the first 3 years. And then after that, when the stock value was much higher, they went public. All right. So there is this knothole of the first 3 years. Now, one of the technologies that this is built upon is digital twins. And I'm showing this slide mainly to differentiate between the two different types of digital twins that are marketed in the industrial space, and hone in on the type of digital twin that I'm talking about for EAAS. So there are digital twins that are, you see in the upper right-hand corner, that are based on 3D models. In this case, I have pumps and driven by an electric motor. They're adding an additional pump. The 3D digital twin is used to see whether or not the pump will fit, to reduce the cost of the construction of that particular instance. All right. And then we see another type of digital twin based on a mathematical algorithm. And That is represented by the glasses with the formulas behind it. And this is a digital twin that analyzes the condition of the asset. Most often, it is used for predictive maintenance in our research. Lately, some people are adding operational performance of the asset into the condition monitoring. With the availability of 5G or the cellular networks in general, this gets around cybersecurity somewhat and also Wi-Fi issues. So we see the IT departments among end users are sometimes very reluctant to poke a hole in their cybersecurity Wi-Fi to allow an OEM access to the equipment on the plant floor. So an alternative to that is to use cellular networks, particularly 5G with a low latency. So for equipment manufacturers, the last bullet on here is there is a huge benefit that a lot of equipment manufacturers have mentioned to me. In fact, some went for this benefit first before they offered predictive maintenance condition monitoring as a service to their customers. And that is the feedback to the design engineers. Most equipment manufacturers, when they design a new piece of equipment, put it on a test bed, maybe 5 or 6 prototypes type of thing, run those prototypes, gather data from the prototypes, and use that to optimize the design. When you are monitoring equipment in actual real applications, the fidelity of that data is, and the realness of it, real applications, are a huge benefit to the design engineer to design the next generation of that asset or that piece of particular model number. So, and that improvement of your design becomes another type of core competitive advantage because your piece of equipment will be better than anybody else's piece of equipment who don't do this kind of condition monitoring in a customer's asset. So there is one aspect that you do enable with a digital twin, enable a new kind of service to monitor the condition, offer predictive maintenance, and improve the uptime of your equipment for your end user, and you have happier customers as a result. But there's another benefit around this design optimization that is also very key and strategic in its importance. So essentially, this EAA service is enabled by having digital twins that perform remote monitoring, and those digital twins are essentially predictive analytics. All right. Now, let's talk about the robustness of this digital twin. What I mean by condition monitoring is it's similar to the oil light on your car's dashboard. It's basically one parameter, your oil pressure, and when that light goes off, you know you have a problem that you should react to immediately. We call that condition monitoring. When you start adding other parameters and you can now do a much more robust form of predictive maintenance so that you can anticipate when something fails, raise an alert before it actually becomes something that you have to stop and immediately address, like when your oil light goes on, right? We find that this is mainly used for predictive maintenance to reduce unplanned downtime, but it also does reduce maintenance costs because compared to the preventative maintenance, predictive maintenance cuts your maintenance costs in about half. And it's beyond the discussion here. We can talk about that otherwise, but predictive maintenance is a much lower approach. In case of an OEM, if you were to use predictive maintenance as a way to support the maintenance of equipment in your customer site, you'd have to do a lot of inspections and sending people there and to see whether or not maintenance is required. With predictive maintenance and remote monitoring, you know that maintenance is required, and you probably know what kind of maintenance is required. So you can arrive with the right spare parts and the technician with the correct skills to make the change. So the first time fix rate goes way up.
So Ralph, hey, we do have a question here, just
Sure.
to maybe insert it as you're going through your
Go
presentation.
ahead, please do.
I think it was from maybe a slide or two ago, but I think it applies to kind of where you are. Ryan asked, all these solutions, are they managed and developed in-house by a dedicated resource, or are they dependent on a software solution vendor to scope and develop?
Yeah, so typically they are use a cloud service. So it could be something like Amazon Web Services, Google, Microsoft Azure for the analytics in the cloud. And it requires skills that are software related. Now, most OEMs nowadays have plenty of software skills in the product development side, but it may not. But they may not have the particular skills necessary to do an application in the cloud. So we find a lot of OEMs go to global services providers, and I mean people like Tata Consulting Services or LTTS, L&T Technology Services, maybe Infosys, those kinds of people to augment the skill sets they have internally to put the application in the cloud and get the communications working effectively with resources that are widely dispersed. So it would be a combination of internal resources because you're so familiar with the equipment and understand how it operates in great detail. There's no one better than the OEM to write the analytics, but often they go to a global service provider to understand how to get the technical skills rather to have this thing operate in the cloud and communicate to a variety of assets.
That's really interesting because I think you hit on something there that I hadn't really thought of, but maybe just in case anybody else missed it or the light bulb went off for them. So you said something really key. So it's from an OEM, right? Because it's their equipment that they're going to sell it out. They may not have the expertise in the cloud, so they can get that resource, but
Yes.
they know their equipment probably better than anybody else because
Yes.
especially because they can look at what's failed, what's worked, where challenges are, where our challenges are, maybe all the aspects of the yields and these things, and they are better suited probably than anybody else, like you said, to develop that AI algorithm or ML or whatever it may be. So you kind of get the best of both worlds. So you're really getting a performant product, not only now, but probably for the future as well. So that's really interesting.
Agree. And what we've seen talking with OEMs about this is a lot of OEMs have a variety of configurations. So there's a core part of the equipment that is standard or repeated across all the equipment, or maybe it's a core technology. And they are best, they may actually write an algorithm, their own algorithm for the core of the product. But there is a bunch of different configurations, maybe thousands of configurations. So to modify that core for thousands of configurations would be a huge effort. So what we see is that they use the predictive analytics in combination with AI or machine learning. So the machine learning really is used for the variety of configurations. And also there may be some variation depending on the particular customer's application of that asset. Think of a pump, somebody may be pumping oil, somebody else may be pumping water. There may be some variety in terms of the analytics that's required as a result. So we often see the core being their own predictive analytics, writing those formulas, and then the variety served by machine learning, maybe.
Yeah, as somebody that's been, or that, yeah, have been in the thick of it, I can definitely comment to it as well. So for Ingersoll Rand, we have a similar initiative and platform development. And so we've gone down initially, couple of developers developing something on Amazon, and later on we went with a platform vendor, so an IoT platform vendor, to kind of help us get the data organized, and they had some tools to kind of front end the information back to us. And then we, after trying that a couple of times, we then actually went directly with Google and developing a solution there, or have been developing a solution there through them. And so it depends on really the maturity and where the OEM is. And I think for small and medium-sized OEMs, I think there's a lot of different platform vendors out there that can help them identify, what hardware to get the data out of their control systems, and then how to get that data into their cloud platform environment, organize it, structure it, and then make it available to themselves for their service, plus maybe their customers, if that's what they're looking at. And there's a lot of different aspects to it for sure. I would say you talked a little bit about the different models and different structures of the machines. There's going to be a good level of work on just standardizing your information, because you want the analytics to be easy to deploy. And if you don't use the same terminology from machine to machine to machine, it becomes very hard to deploy a standard algorithm, right? So there's a lot of standardization you got to look at, and then you got to look at you might have 20 years of install base at different versions of the control system that has more or less type of integration, more or less data. So there's a lot of that aspect to it as well. So, but yeah, absolutely. There's either you have the technology in-house, the people in-house that can develop part of this, but you do have to rely, as you say, some external companies, service providers in some way, typically for some level of this. I think this is not core competency from an OEM, right? They're not a software provider, they're not an integrator, but they do provide software for the equipment, right? And so there's a give and take, and I think larger OEMs start developing their own department that has all that capability, and others go with some platform vendor and some service provider initially, and then maybe grow over time, I think, too.
Yes, yeah, I think I would agree with you wholeheartedly. One little caution: if you were to Google IoT platform, cloud platform provider, I would guess you'd come up with maybe tens of thousands of hits. I haven't done it recently. So choosing a platform provider is not all that easy. One of the benefits of people like AWS and Google and Microsoft Azure is that the analytics is very robust on there, perhaps sometimes far more than an OEM would require. The structured data management associated with equipment, meaning what I mean by structured is you want the 7 or 8, 10 values that you collect from a piece of equipment to be always associated with that particular piece of equipment. I would suggest avoiding data lakes where you dump everything into one big database and hope some analytics, some machine AI can figure it out. You want to keep it structured, is one thing. And the second thing is that the communications to your equipment and perhaps the variety of types of communications that may be required. Sometimes that's very specific to an industry, and you may need to go to a platform that supports that kind of communications rather than create it yourself. Yeah.
Yeah, absolutely, absolutely. I think you hit on some points there for sure. So choosing a platform vendor, you really have to get some idea of what have they done in the past, because there's a huge difference between like an IoT vendor that's going to connect to, let's say, thermostats. Very, very simple application, very few data points, very similar across the board, right? When you go to an industrial manufacturer of equipment at different levels, it becomes 10, 100 times more complex. And so you got to have a platform vendor that has experience with industrials. You almost got to have a platform vendor that has some experience in the industrial automation, that at least know how to relate to it. Like, how does this compare to a SCADA system? How does it compare to a historian? How does it compare to an MES system? At least have that level of knowledge of the space before, if they say, we have these, you know, thousands of customers, and then you look at the customers and they're all like the traditional consumer IoT type customers, then it's not the right one. You got to have someone that has experience in the industrial side, because it is more complex for sure.
Agree. Yes. Yeah.
So Ralph, I'm going to interrupt your presentation again because
Go
we have
ahead,
another
please.
question here. So keep this dialogue going. We'll keep it Clubhouse style. So, the OEMs are, and I think when you look at this question here, this is from Carol. Are OEMs taking into consideration the integration of SaaS solutions for their equipment? And yeah, I guess that's the generic question here. And I guess you could look at that from an equipment as a service or just in general. What are your thoughts there?
Yeah. So there's two aspects for this to answer that question. One is around just offering remote condition monitoring. So an OEM sells equipment, offers remote condition monitoring, and but sells the equipment in the traditional business model, meaning a large upfront sale. But they offer as an aftermarket remote condition monitoring. Those there are a lot of OEMs are doing that, and that has certainly got a lot of success. I could talk about that and why some have been successful and why some haven't. That's a little bit of a tangent. I don't want to go down that tangent right now. In terms of offering EAAS, changing the business model where I'm not charging a large upfront fee, and instead I'm offering a monthly charge, a yearly charge. That is on very much the leading edge. It's emerging, meaning that to the best of my knowledge, there are not many suppliers who are doing it yet. And I offer it here as a thought for increasing the stockholder value of a company and motivating senior management to change their business model and go through that 3-year knothole to a much bigger reward later on. Most boards of directors and C-suite people right now are looking into that knothole and are reluctant to go through it right now. So bringing up the price to earning ratio and shareholder value is a fairly new approach to this C-suite reluctance, and maybe it'll help them get through that knothole.
So that's a good, I think, segue into the discussion around the difference. I mean, you mentioned condition monitoring services or servitization, whatever. So if you are going down this route of equipment as a service, you got to find a way to justify, because customers are not stupid, right? When they see that they're gonna pay 30%, but over 10 years, it's 300% of the machine, but it's still over 10 years. So they're looking at different way to finance it, et cetera. But at the same time, they got to have some extra value, right? And that's where the IoT comes in, so you can really provide that lower your overall downtime, increase uptime. You have shorter cycles to fix things, and you have potentially with with condition monitoring and predictive monitoring, you can even potentially prevent something from happening before it happens to keep the uptime. So there are some guarantees typically that I think you have to kind of tie in with that we're going to have 99% uptime or something like that, or other things like that, in order for customers to say this is really, really valuable. What are some of the other things that you have kind of talked to OEMs about of how do they get customers to buy into this new model, as opposed to just them, because from a customer perspective, they could just still finance it, the initial cost somehow, so it's still going to be spread over some years, which they typically would do anyway, probably. So what makes them think this is a better deal? I mean, the idea, of course, is that they is spread over. They're probably less tied to you. They could switch over based on the contract, whatever. So there's some options here. But what have you heard, or what have you talked to OEMs
Sure.
about?
So let me bring up another aspect of this that is not had much visibility. And first, I'll talk about it from the perspective of software as a service. One of the underlying things that was going on there was essentially outsourcing maintenance. I mean, maintenance of the servers in the data center. So companies had to have their own internal data center to house the on-premise applications, the perpetual license applications. When it goes to the cloud, they don't need those data centers anymore, and they don't need the IT people who maintained that data center. So one aspect of it is in the case of EaaS, in a similar way, is outsourcing maintenance, and it also at the same time achieving higher uptime, less unplanned downtime to the OEM. So the OEM becomes responsible for the maintenance rather than the internal staff. Now, if you're thinking of a simple pump, that may be a bit of a problem. Why, my staff can maintain a piece of equipment easily. But we all know that equipment is getting more and more complicated. And an extreme of this example is the semiconductor industry, where you're talking very complicated equipment to make state-of-the-art semiconductor. And there is no way an on-site maintenance team can maintain that equipment in the semiconductor industry. We see this complexity of equipment going well beyond the semiconductor industry, and keeping on-site people trained on complex equipment is becoming increasingly difficult. I mean, you could send some people to training, and of course OEMs offer training. They go to training, they learn how to maintain the complex equipment, but that training decays, and also the problem may be one that they didn't cover during training. Someone who's constantly maintaining this equipment and who has expert to very expert people can do a much better job of maintaining the equipment than on-site people. So outsourcing, another aspect of this is actually outsourcing the maintenance function for increasingly complicated equipment.
Yeah, we talk a lot about this in Industry 4.0 Club. It is really with the change of the workforce. You see less and less of the maintenance tech that stays with a company 15, 20, 25 years. You see a lot of changeover. You see a lot of millennials and Gen Zs coming in, and they don't even expect to ever fully learn everything about a machine. They just like everything else, right? You Google or YouTube, how am I supposed to fix this and find that out, right? They expect that kind of level of information. And that's where OEMs can come in, either by providing that expertise themselves or providing some of the newer technology around remote direction or AR, VR kind of stuff. But again, with these type of solution, of course, it's a all in full service model, right? So again, from that perspective, I can see definitely that's a value as well, that you don't have to think about having your staff fully trained on those, and you might not even have to worry about monitoring the machine, because the company will know ahead of time that something has already broken or it's going to break, and they'll have somebody on site and fix it before you even realize it. So it is definitely a different type of business model and service model, and I'm just really, it's still something where I think, especially from an OEM, which I've been in the OEM industry for over 25 years, and there's always been a discussion about instead of buying the equipment, you buy it as a service, you buy per click or something. But when the customer kind of looks at the total financial picture of that, and then they realize, well, I can still go and lend the money. I can pay it over time. Very rarely does it actually become reality that you're financing the equipment and the service. And so there's still that hurdle that I think equipment manufacturers are struggling with, is how do they really make sure the customer sees the full value of this? Because there's tons of value. If they're doing the digital twin and AI and insights and predictiveness properly, there's a lot of value in this. And the only way they can get to that level really is if they own the equipment, right? So,
yeah, let me reinforce what you just said. If the evaluation is only based on the financial aspects of the large upfront investment, meaning instead of paying 100% upfront, paying 30% per year, if that's the only financial analysis done, then that's a difficult situation. The real value is having far superior maintenance done on that machine. You have higher uptime, particularly no unplanned downtime. Now, let me just think about the ramification of unplanned downtime. That occurs when the asset is being used. And when it goes down, product cannot be made and they lose revenue. When you start talking about lost revenue, that gets C-suite attention and makes a huge improvement in the evaluation, a financial evaluation from a C-suite perspective. You also, when you have unplanned downtime, you get into safety issues. That's usually when things cascade into a much bigger problem. So you may have a vibration problem, but if it's not addressed, it eventually has gears blowing up and those broken teeth getting into other things and causing a huge problem, as an example of one example. So it avoids a small problem exploding into a much larger problem, as an example, and other things. So if you take it beyond predictive maintenance, and also the OEM provides some operational suggestions, maybe the operator isn't running the piece of equipment optimally. Maybe you can provide some operator training so the piece of equipment performs better and lasts longer. All those kinds of benefits become part of EAAS.
So Ralph, this is a fantastic conversation here. I am curious, just looking at the other side of the coin, because I think most of what we've discussed here so far is the positives of EAAS. What are the cons? What are the negatives? And one of that comes to my mind, it's not necessarily a con. I'm just kind of curious what happens with it. But what happens if there's a company that purchases an EAAS from an OEM, and then they go out of business, or they no longer need the equipment, and they stop paying on that? Does that the OEM wouldn't have gotten full price for their equipment, and now it's sitting at a manufacturer site? Like, how does that look, and or what other negatives or what other considerations is maybe a better way to put it that should be considered with this platform?
Yeah, there's two things come to mind. One is where the company has a change in business or whatever, doesn't need the equipment anymore and returns it to the supplier. Well, the supplier can refurbish it and basically offer it back out as an EAAS and at that point the asset is depreciated, so the return on asset from the OEM viewpoint probably is a lot higher. So there's no problem, I think, in this model with refurbishing the equipment and offering it back out. The second part of it is, what if the company goes bankrupt and the doors are locked and the OEM can't get their piece of equipment off the plant floor? And in that case, I think you got to have the lawyer consider that as part of the agreement with the end user, and perhaps a lawyer can mitigate that a little bit in the agreement. I'm not expert enough in bankruptcy law to provide good advice in that area.
Yeah, there's definitely some areas around the economics and maybe even tax that people will need to be fully aware of. One of the things I just want to mention too, just a quick reset if somebody coming in here late. This is our Tuesday room on Industry 4.0 Club that we today have here on LinkedIn Live. We are joined by Ralph Rio from ARC Advisory Group, talking about equipment as a service. And as you've probably seen, all of you, we are live streaming this on LinkedIn Live. So if you have a question for Ralph, you can definitely post it on the comment section in LinkedIn Live, and we will bring that back into the room here. But back to the economics of it, of the cons, so to speak. There is definitely some to think about, and again, just like Ralph, I'm not an expert either. But so, for example, when you change to this business model, as maybe even a Fortune 500 company, suddenly you're going to have a lot of equipment on your books that you didn't have before, right? So you got to figure out, what does that look like, and how do you justify that to the market that there's a change in your business? This is how you do it. I've seen a couple of references to some case stories where companies goes into some kind of joint venture. So they create a separate company to carry the assets, so that in that way it's not really hidden, but at the same time it's not the main company that is carrying those assets. So it looks a little bit different that way. In the industry I'm out of, which is compressed air, we have the term air over the fence. And what that means is that instead of putting the equipment on the customer's property, we're leasing something right over the fence at that customer, leasing some space, whatever, build a small building or put a container there with the equipment in it, and then run a pipe over to the customer for that air. So that's a term there. And I'm not fully familiar about why the equipment is not on the customer's property, but I can assume something we just talked about. What if the company goes bankrupt? I don't have access to it. There can be some tax issues around how do you make sure that the company only count the equipment that they actually own on their property. There'll be a lot of different areas that definitely somebody needs to fully go in and revisit before they go into something like this. And I think the biggest one that I've heard about is that you suddenly got to carry significant amount of assets on your books that you didn't do before, right? And you got to depreciate that over time, et cetera. So there's some complexity around that companies might not want to be interested in going into.
Yeah, that's certainly got to be part of the financial evaluation. I would comment that in addition to bankruptcy laws being complicated, I found that the IRS laws for how you account for things also becomes quite complex. So rules that apply to leasing probably don't apply to EAAS. So we've noticed that there's a subtlety with software as a service that if it runs in a browser, the IRS will allow you to call it a software as a service, and it gets certain treatment. But if it requires software to be installed on your equipment, like in most of the engineering design software, they really can't call it software as a service. You'll see them use the term subscription services, and there's a different accounting for it because some software is installed on site, even though the payment is made on a periodic basis.
Yeah, that's a good point. I just want to also just mention we're running close to the end of the allotted hour here. So Ralph, if you had some other points, some other slides you wanted to show, I want to make sure that you get to that as well. And then go ahead.
Yeah, just go through the conclusions quickly. The knothole for executives is the first few years revenue hit because they're not getting the large upfront revenue. They're getting EAS, roughly 30% per year revenue. And the key benefit comes after year 3. Some people, there are a variety of ways to deal with that. Some of them go private. Some take much longer than the 3 years to implement this. There's a variety of ways. And in the case of AutoCAD, they were willing to take the hit. So they converted their customer base over to software as a service, and they took the initial hit on the price of the stock. And now it's doing quite well because they're past that knothole. So each management team needs to figure out how they want to address the first 3 years. The remote monitoring from a end user perspective assures high uptime, no unplanned downtime, and that gives the end user very high customer satisfaction because they're much more likely to ship product on time. From the OEM's perspective, that also gives much higher customer satisfaction. I know when I was an OEM buying equipment, when I was an end user buying equipment, when equipment went down, there were some ugly conversations with the equipment manufacturer, and the likelihood of me buying that a piece of equipment when I needed some more dramatically reduced. But if you're providing remote monitoring, I have high uptime, I'm going to be a much higher end user customer, and I'm much more likely to buy more equipment from you. And the last bullet there is it's important to monitor your digital twin's performance. Is it really predicting unplanned downtime or maintenance issues? And so you should be always looking at false positives and false negatives and tracking that over time to figure out if it's a good one and good digital twin, and also to figure out how to improve it over time too. Measuring the digital twin's performance and continuous improvement is often overlooked, but key to successful program. So, are there any other questions from the audience? We've got.
There is one question here from VK. He says, "Is there a number on the maintenance cost as a % of the initial purchase price by industry segment? So is that percent that can be reduced by the OEM, then the customer may want to take up the OEM's maintenance offering." So basically looking at, so if you say we're paying 30% per year over the next 10 years, have you seen different percentages that could be applied to different industries based on their probably traditional maintenance model, right?
Boy, that's going to vary all over a lot depending on how much on-site maintenance was required and whether or not the maintenance team could really do it. The local maintenance team on-site could do it. you know, I'll take the case of the semiconductor equipment industry where in some cases the annual charge is large enough where they can have a person full-time on site, an employee of the OEM full-time on site. So you can imagine that the monthly or annual charge is pretty significant. In other cases, not so much. So that requires some evaluation answering that question, and I cannot provide a overall percentage that would fit any situation.
Yeah, I mean, if you think about different industries, I think your example of the semiconductor industry is a good one, right? There'll be others as well that even without EAS, they have service contract where there's people on site. So there's a high level of service, and then there's others where it's probably a lot less, where the machinery is not as complex, easy to replace parts, etc. So that it's less there. It's hard to come up with a general around different industries for sure. But
yeah, let me talk about, you know, some people may be thinking that you know, their equipment is all that not all that complex and you shouldn't worry about it. But I'm going to talk about my furnace that I bought about 2 years ago. And now furnaces, I live in New York State, so having a reliable heating system is pretty damn important, particularly in January when it gets down to 0 degrees sometimes. So reliability was a bit of an issue for me. But today's 95% efficient furnaces are actually very complicated. And when they installed it, now I'm a geek. I'll admit I'm a geek. I read the owner's manual, the installation manual. I understood how it should be installed. When the people who install equipment, now these are the millennials that, you know, you spoke about before, who don't stay on a job all that often. They were the installation crew. They made 4 very significant mistakes, which I'm not going to get into in detail, that I discovered. And if those went undiscovered, I would have had a horrible problem when it's 0 degrees out. I would have had a horrible time with my thermostat and other issues. Now, I'm a geek engineer and I figured this out, but you know, the average homeowner would have been stuck with these problems, and they probably would have been recurrent problems. Now, I did have to call someone back in because I didn't want to make the changes myself to make the changes. And they brought in their very experienced technician who knew this stuff inside and out. He figured out that those 4 issues were really problems, and he made corrections and checked out the system to make sure there weren't any other problems. All right. So my point is, even a furnace, which you would think for the millions of homes there are in the United States would be fairly easy to install and maintain, even furnaces have these kinds of issues. Now, at that time I bought the furnace, I could not find a supplier who offered remote condition monitoring. All right. But, or I would have gone with that supplier because I understood how critical and how susceptible these pieces of equipment are to an extended unplanned downtime. So I just give that as an example of where outsourcing the maintenance to the OEM would have been a desired outcome.
Yeah. No, that's a good example, and something that most people can relate to for sure. And I see the same with, you know, in OEM equipment in general, that their OEM equipment that's been out for years and years and years, right? But it's still, oftentimes they break for the same reasons. They're the same parts that typically has to be replaced so and so often, and you want to have somebody maintaining that, make sure. So here in North Carolina, where I am, I don't know if everybody does that, but most of the vendors, they do have those annual agreements where they come out twice a year, check the air condition in the spring, and then they check the furnace in the fall, right? And just having that knowledge that they've checked everything to make sure everything's fine, that's always good to know, right? So, but there's an extra cost, and I haven't seen any air conditioned furnace as a service yet for homeowners, but that might be a next step. So
Yes. Yeah.
no, this was
I think
was
some of
very
the core issue is that these equipment manufacturers are in the management structure who've been around for perhaps decades, are very comfortable with the mechanics of their equipment and are extremely uncomfortable with the software because that's new with them. And the idea of offering remote monitoring is probably doubly uncomfortable, where they barely, in some cases, understand the internet and how to use their smartphones. Don't quote me on that one, by the way.
So I think we're pretty much out of time here, but there is an interesting question that just came in from the Industry 4.0 Club.
Okay.
And I think it plays into what you just said, and it may need to be explored in more detail at another time. I don't know. But, with this connectivity that we just spoke about, and quite frankly, what you just said about the understanding of kind of where people's heads are in terms of the software and development and in the cloud and those kind of things. Are there any concerns about the remote equipment monitoring and cyber attacks and cybersecurity?
Yeah, well, that is definitely a concern. And we have analysts at ARC who focus just on cybersecurity for operating equipment versus IT equipment. There are plenty of analysts for IT equipment. But we have people who focus just on cybersecurity for operating equipment. And there are solutions out there. I personally am not knowledgeable in that regard. We have some other analysts who research that area full time, and they've given me enough confidence to be able to tell you that there are solutions out there that do work.
Okay.
Yeah, but to Ira's point here, we're just a minute over here. So what I'd like to do is to just quickly, give a little synopsis, and then have you, Ralph, do some closing comments. But just here, thank everyone for joining and for your time. And again, this was Industry 4.0 Club, our Tuesday room on manufacturing futures, and we were our guest here today, Ralph Rio from ARC, was talking about equipment as a service and providing some good information around where some of the C-suite people are thinking right now, comparing this to the software industry, which has a great success with this particular type of business model. And I'm sure, yes, it's not fully there yet. We're still kind of working on it, but I think some of this will happen in a lot of different industries because it is a different business model, and there's definitely some other revenue to look at that could be very interesting. But Ralph, any final comments from your perspective?
Yes, just one item. If your C-suite is uncomfortable with this kind of software, and you need to move them outside of their comfort zone and into this arena, start talking about price to earnings ratio. Not only will they start listening to you then because it plays directly into their KPIs, but it'll probably improve your career prospects because they will see someone who understands the performance and stockholders' value.
Very, very good. Very good. I think this has been a great conversation, Ralph. I've enjoyed your perspective, and it has opened my eyes to some opportunities that is going to be interesting going forward. See what kind of industries are going to be able to adopt this new business model, and I'm going to look forward to any company that suddenly goes private and I have an idea what they're trying to do. So it's going to be interesting to see. But again, this was Industry 4.0 Club. If you like having these type of conversations as much as we do, please join our scheduled rooms on Clubhouse or LinkedIn Live. We have them every weekday, Monday through Thursday, at around noontime, just as today. You can find the schedule on www.industry40club.com or on LinkedIn as well. And Ira, you have a quick comment before we close?
I was pointing at the Industry 4.0 Club sign as you said it. That's what I was doing. So no, I thought this was a fantastic conversation, and I really appreciate it, because a lot of times when we talk about this topic, we always talk about more end user type things, and understanding it from the OEM perspective was fantastic. So thank you so much for your time, Ralph. It was amazing.
You're welcome.
So I appreciate it.
Thank you very much, Ralph. Really enjoyed it, and we're gonna look for maybe bringing you back in a later room here over the year, because you have a lot of different topics you're working on, or somebody else from ARC, and you guys have a lot of good stuff that you're talking about. So this shouldn't be the last time. So we'll see how it goes. But thanks everyone for joining again, and really appreciate the time, Ralph, today.
You're quite welcome. Glad to help.
Thanks a lot, guys.
Okay. We will go and close the room here, and thanks everyone for joining again.